Hello and welcome to Leetcode Camp. I'm Prashant and today we're going to be learning about two very important data structures in Java. One of them is hashset and the other one is hashmap. And before starting this video, if you are not familiar with hashset and hashmap, I would want you to pause the video and just go to Google, just learn a little bit, just take 5-10 minutes, learn about what hashset is, what hashmap is, what the set interface is, what the map interface is in Java, and come back to the video and resume. So let's get started. So the problem we're going to be solving today is finding the duplicate number. So it is labeled as a Leetcode medium problem, but I still think it's a pretty easy problem. It's still a beginner level, but I hope you understand what hashmap and hashset is by now, but let me give you a quick overview though, just quickly enough. So so these are both data structures like hashmap and hashset, and if you store, let's say like we have an array right here, right? So if we store this in a hash map, then we will need to store this array as a key value pair. So the key, it's up to you to define what the key and value is depending on the problem, but you could say the keys could be the actual number. So you could say the keys could be 1, 3, 4, 2, and 2. And then the value could be, let's say it could be the frequency of the number, right? Like the number of times the value is repeated. So 1 is repeated just one time in the array, 3 is repeated just one time in the array, 1, and then 2. We cannot put the same key 2 times, sorry about that. But yeah, so 2 is repeated 2 times. Just the key has to be unique always, keep that in mind. And then hashset is just a key pair. There's no value, it's not a key value pair, it's just a key. Like you just store, it's a data structure where you just store a bunch of keys. So 1, 3, 4, 2. So now why do we use hashmap or hashset? So using one for loop, we can put the key value pair, or we can generate a key pair when it comes to hashset. The beauty of doing this is because every time we're trying to do a search or like a get method, then hashset and hashmap does it in constant time compared to like an array. So in the array, like if you look at the array right here, you could, if you wanted to search for 4, then you'd have to start from 1, then go to 3, then 4, right? Like a linear search. Or if you're looking for 2, then you have to start from 1, 3, 4, 2, 2 again. But the reason hashmap is so powerful is because if you want to look for 4 in the hashmap, then it will just find it right there. So the implementation, if you're curious how it works, then you should go more like Google search and learn more, but it's not really that necessary. But the main thing you have to understand is searching or retrieving a data from hashmap or hashset runs in O of 1. It's constant. However, in array, it's going to run in O of n, since it's a linear search like we discussed yesterday as well. Okay, anyways. So now you know what hashmap and hashset is. The problem we're going to be solving today is finding the duplicate number. I'm going to be doing the coding sections pretty fast because, like I said, it's not really that difficult of a problem, but I can show you 3 different ways to do it. So one of them is simply sorting and comparing. The other way I can do is using the hashmap, so that you'll have a practice like with hashmap, you'll see how it's implemented. And the third one is using hashset. So without any delay, let's start the coding. So the sorting and comparing is going to be something like, first things first, you're going to sort the array. So why are we doing this? Let me show you. So the array, the example given to us on the left is 1, 3, 4, 2, 2, right? And we're supposed to find a duplicate number in the array. So given the array where each integer is between 1 and n, so it's all positive integers, prove that at least one duplicate number must exist. So assume that there is only one duplicate number. So there's only one duplicate number in the whole array always, and then you just have to prove that it exists. You just have to return. So what are we returning? We're returning the whichever number is the duplicate, we're returning that value. So in this first example, 2 is the duplicate, so we're returning 2. In the second example, 3 is the duplicate, so we're returning 3. So the first one, look at this, like the two twos are together, right? So you could have compared the first one with the second one and then seen like if they are together, just like brainstorming, you would know like this their duplicate exists. So that's the reason we're sorting here. So look at the bottom array. So it's 3 1 3 4 2. So if we sort this first, it's going to turn into 1 2 3 3 4. So now we can go through the array with a for loop, and then we can see for each number and the adjacent number. So each number and the adjacent number is next to it. If these two numbers are equal, then we're just going to return that number because that's a duplicate. But it's same thing, first with the second, then we're going to compare second with the third, and so on until we reach the very end. So that's the logic behind the implementation. So let's do that real quick. For int I equals 0, I is less than nums length, I plus plus. Let's say if nums I is the, let's say nums first value is happens to be equals to the adjacent value I plus 1, then we're going to return the number. And then so since the function is looking for an integer return value, so we have to give a return value out here. I mean, it's never going to go out of the for loop because the program says there's at least one duplicate number, and there's only one duplicate number, so it will find the duplicate number and it's just going to return right here and terminate the program. But to make sure it compiles, so right now look at this, if I do run code, it's not going to compile because it's going to say missing return statement or something because we have not put a return value outside the for loop. So just to make it return, you could do like 0 1, doesn't matter, but the numbers says like 1 to n, so it's positive number, so you could just do -1. It's just better, you know, but it's not really gonna matter too much. So now we run the code. And that's it, it's gonna work. Let's try to submit it. So okay, first submission 3 ms. So it says it's faster than 25% of Java submissions, but I would say don't look too much into the percentage and whatnot. The way you should calculate the efficiency of your program, the runtime, is look at the program itself. So in this sorting, like just know most sorting algorithms are O n log n runtime. So this is something you should just remember for now. There are like better sorting algorithms which work less than n log n, and potentially it can go all the way till n. So there are some which I'm going to explain later in the videos, upcoming videos. I'm going to do problems which can be optimized using even better sorts, but for now just doing a sort method from the arrays class is going to give you n log n runtime right here, and then the for loop out here is going to be O of n runtime because you are going from the first element to the last element, right? Oh, one little mistake. I mean, the program didn't really catch that, but it's better to do nums at length -1 because let's say assuming the array did not have the value, because when you're searching, like when you're doing a search, there could be problems where there's no values, right? This is done to avoid null pointer exception. Let me show you. So look at the 0th index and then look at the next index. It's going to compare 1 with 3, right? So I'm just going to make another array right here, just so let's say none of the numbers are similar, something like that. Then let's say you compare the first one with the second value. So I is 0 and then I plus 1 is 1. Now you compare, now the next I is 1, you compare it with the third value. Now you compare the third one with the fourth value, and finally you have to stop right here. Now in the fourth value, this is where you have to stop. So you have to compare 2 with 7 and then stop. So if you went only nums.length less than nums.length, because the length of this array is 5, so less than 5 means index 4, which is the last index, right? So if you go only till here, then if you go till here, then the final loop, what's going to happen? It's going to try to compare 7 with the element behind it. which is null, so there's nothing behind it, so you're going to get a null pointer exception and the program will crash. So you should not go till nums.length less than nums.length. You should not go till less than 5, but you're supposed to go till less than 5 minus 1, so you're supposed to go just till second last element rather, if that makes sense. Let me get rid of this comment now. Okay, so the for loop is O of n, and then the sorting algorithm is O of n log n. So the overall program is O of n log n plus n, which is, you can sum it because n log n is bigger than n, like it's much more slower than n. So you can just say the efficiency, the runtime efficiency of this program is O of n log n, which is actually pretty slow. Like it's a naive solution. So I'm going to implement it with a hash map now to make it better. So I'll show you how it's done. Okay, so now let's do it with a hash map. So first things first, let's implement a hash map which is going to store the integer values as keys, and then we're going to put the number of times it's repeating. So let's put the integer values again as values, right? Key and value pair. So let's call it hash map is a new hash map, and then okay, so you can implement this, just call the map interface rather than the hash map. It is how you achieve polymorphism in Java. It's one of the 4 pillars of object-oriented principles, and it's very important. So just know, like, hash map implements the map interface in Java, which is why if you implement it using map, you can access a lot more functions that, and then even though it's a hash map object, so you should go Google, like, if you don't know what polymorphism is, and then you should just go and like Google the concepts and it will be clear to you what I'm doing here. But yeah, moving onwards. So what's our next step? Put everything in array into hash map. Let's do it. So for every single num of nums, if you're not familiar with this kind of for loop, it's just advanced for loop. So if you don't need index anymore, like for this for loop, I'm not gonna need an index, so I'm just gonna use the advanced for loop. It's so much easier and the code looks cleaner. So int num of the array nums, right? So for each of the nums, if hash map does not contains the key, does not contain the key number, then we're going to, sorry, what am I doing? Okay, we're going to put the number with key 1. I'm going to, don't worry about it for now, I'm going to walk you through the whole thing. Else hash map dot put the number again, but it's going to put hash map dot get num plus 1. Okay, I'm gonna walk you through the whole thing of the for loop. So we're just trying to populate the hash map at this point, right? So let me get rid of. Okay, so look at our array. We have 1, 3, 4, 2, 2. So for each of the number, we are trying to put the hash map in there, right? So we're just trying to put everything in hash map. So first number is 1. So look at this. Does the hash map contain 1 yet? No, it does not, right? It's empty. Hash map is empty, so it does not contain 1. So if it does not contain the 1, then we're going to put that 1, and then the frequency of that is going to be 1. That will be our value. So we're going to put 1, and the value is going to be 1. Cool. So now look at the next one. 3. Does the hash map contain 3? No, it does not. So put the value, make it frequency 1. Does the hash map contain 4? Nope. So 4 and 1. Does the hash map contain 2? No, it does not. So 2 and then 1. Now, for the last number 2, does the hash map contain 2? Yes, it does. So look at that. If the hash map does not contain, then we were putting it, but now it does. So we're going to the else part. So now we're going to put num. So remember how the key out here is just the same thing. So if the key is already present, it's not going to add another one. It's just going to replace that. Basically, you're doing hash map that replace is the same thing. So even if you do put, like if the key is already present, it's just going to replace the old key. So the old key was 2. Now it's going to replace it with the new key 2. And then what is it going to do? It's going to do hash map dot get num plus 1. It's going to get the value of 2, right? What is the value of 2? 1. So hash map dot get the value of 2 means 1, and then it's going to increment 1 to it. So now it's going to increment 1 to 1, so it's going to be 2. So now we know there are two 2's in the hash map, so we know there's a duplicate, but now we have to return the number 2, right? So how do we return the number 2? It's going to be done in another for loop. So we have to, okay, so all these methods like get, put, all these things you can look in the you can just go to hash map API Java, just go there and just look at that, just for your reference. You can find a lot of good methods that is used. Look at that, like clear, clone, compute. You're not going to need all of these, but see, contents key, that's the one I had used. Entry set is another one I'm going to use, and then get, right? So there's put if absent. These are pretty like important ones, but you can go through it and then use either whichever ones feels like the best use in the program, but do the same for hash set too. So this is how you would know the methods. But let's go to the program. Okay, so okay, sorry, I'm just going to show this once more. I wanted to show you one thing. So look at the entry set method right here. So entry set returns a set of mappings. So it's going to return a set of map.entry kv. So you can do like a for loop is going to be something like, so we're gonna need map.entry of integer and integer, since our hash map contains integers, right? And then let's call this entry, and then loop through hash map.entry set. So loop through all the entry sets, like every single map.entries in the entry set. Remember how the API returned entry sets? So loop through all of it, and then for each of the entry, if entry.getValue, if either one of the entry, because there's one entry which is going to have a duplicate value, right? So if entry.getValue is greater than 1, so there's going to be one value whose frequency is more than 1, then we know that's a duplicate number. So we're going to return entry.getKey, because that's the key we're returning. So it's going to go through the loop. 1, it's not greater than 1, so it's going to pass 3, it's not greater than 1. It's not greater than 1, like the value, it's not greater than 1, but this one, it's greater than 1, it means that's a duplicate. So we're going to return the key, right? I hope that makes sense. If you go through the program 2-3 times, I know it's a little bit confusing for first time, but just keep going through the program and you're going to understand it in no time. But yeah, so that way we return the entry.get key. And remember how, like before, the function wants an int return, so it's not going to go outside the for loop, but we just return a -1 just so the program compiles. Make code a little bit cleaner, get rid of the extra spaces, and then feel like it should be working. Let's try to run the code real quick. And oh yeah, remember, don't press the submit as much as you can. Just try to make sure the code is running, see if all the edge cases are good, and then press submit, So yeah, okay, looks like the first one compiles. And so we have a hash map. First step, we instantiated a hash map, then we used a for loop to put everything in the hash map, right? And then after that we used another for loop and then see if there's a duplicate present. That's it, that's the whole program. Okay, so let's try to submit it. Yeah, cool, there you go. And then so don't, like I said, don't look at the percentage and stuff, it's not really gonna help. So try to calculate the runtime yourself, because okay, so this one appears slower than the previous one, but this is actually faster because we're only looking at 5 datas. We're looking at limited datas, but if you're looking at a bigger data, that's where the runtime actually matters. Like 5 or 10 datas, it doesn't really matter, it's not going to be slow. But if you're looking at like thousands of datas in the industry, so that's when the runtime really matters. And hash map is much faster than sorting and doing the first approach. So the for loop out here is going to be n, right? Because we're going through one number at a time throughout the array. So that's all we're doing, putting in the hash map. And then the for loop out here is also n. So the overall program's runtime is n plus n is equals to O of 2n. But like I said, in programming, this is still considered a linear search. So you just say, if the interviewer asks you what is the runtime, it's O of n. So what? Just ignore the constants in front. It doesn't matter if it's 2 or half or whatever. Just ignore that. Whatever is the variable, that's the runtime. So O of n is still the runtime. If that makes sense. So yeah, this was another approach. Hope that made sense. So let me now do it by implementing the hash set. Let me reset the code. All right. So hash set would be even more faster and the code would be even more cleaner. So look at this. So how would we approach the hash set? Let me do this. So first key 1. So remember in hash set we only store key and not the value. So we put 1. So before we even put 1, my logic is going to be something like, we're going to check, does the hash set contain the key 1? No, it does not. Then that's okay, put 1. Does the hash set contain the key 3? No, it does not. Then put 3. Does the hash set contain the key 4? No, it does not. Put 4. Does the hash set contain the key 2? No, it does not. So put 2. And then does the hash set contain the key 2? Yes, it does. Means it's already there, so we're just going to return 2. That's it. Even more faster. It's done in a single loop, so it's so much faster. Let's make it hash set of integer. It's a single key only, not a value. If there was a value, remember in hash map we would put a value also, but that's all it is. Hash set is a new hash set. All right, so let's loop through the numbers. Hash set. Okay, so first things first, remember we're gonna check if the number is present and then we're going to put it in the hash set. So because, okay, let me do the wrong way first. So first thing, let's put hash set and then num, and then if hash set dot contains num. Actually for hash set it's add. For hash map it was put, but for hash set it's add. Keep that in mind. And then contains key instead of contains key, because hash map has contain key value pair, but hash set only has key, so contains is the method. You can check that going to the API again, the Java's API, okay. So if hash set dot contains num, then we're going to return the num, and then like usual return -1 so that the program compiles. And then, but look at this, look what the problem is here. If hash set dot add num, then first things first, we're adding, so this implementation is going to be bad now. So what we're doing, we're adding 1 first, and then we're checking if hash set dot contains the value. The moment you add it, it's going to contain, even if it's only 1 addition, right? So it's not going to work. But the actual approach that I told you about, first we check if it's there. Is 1 there? No, it's not. Then we add the 1. Now we go to the next value. So which is why the program, this is where you have to be very careful. So let's move, actually let's move this line below the line, and that's it. So first we check if does hash set contain the num, then we return the num. Otherwise, the moment you return, the program will terminate. And then otherwise just add the num and then go to the next number in the loop. So pretty straightforward and so much cleaner, just one for loop. So you know the runtime is O of n for this. Sorry, O of n. So that's it, that's all it takes. And see, that was the one test case is accepted. Let's try all the test cases and submit it. Boom, there you go, faster than 50% too. I mean, this is pretty fast. There's only one for loop involved. Even then, hash map or hash set, both of them is it's good approaches, like in the interview you could do either one, but hash set will definitely give you a plus point because cleaner code, so much like nicer, and then with just one for loop, so definitely better. Sorting, the first approach is not that good of an approach. You could just tell them like I could do it by sorting and then comparing each element to the adjacent element, but it would be faster. So that the sorting would take n log n runtime, but I could drop the runtime down to n runtime O of n, because hash map and hash set both takes O of n, right? So you could do that. However, it's going to take extra space though, like memory uses, you see there. So hash map or hash set, the moment you are initializing a data structure, that's like you're adding O of n space. This is different from runtime though, guys. The runtime is O of n runtime, but it's taking O of n space as well now. So the moment you are making a data structure, you are using a data structure. If you're using another one, suppose like you're making a hash map, another one right here, then the space complexity of your program would be O of 2n. So because you're using two data structures. So I hope that makes sense. This is important too. Like you should be able to tell the employer like my runtime complexity is O of n, but my space complexity is going to be O of n also because I'm using another data structure. So this is one place where if space is a concern for your program, then you would want to use the first approach, the sorting approach, because remember it did not use a hash map or hash set, so the space complexity of that is O of 1. It's constant because it's not using any extra space, just the space that the stack uses, but that's it. So I hope that makes sense, and if you have any questions, let me know down in the comment below. Like I said, this is not that difficult. I know it says medium, but this is actually another easy level question. And what I would like you to do is just do all three approaches, try it on your own, and then get familiar with hash map and hash set. Tomorrow I'll come up with another very beneficial problem. Hope you have a great rest of your day. Take care. Bye.